Good morning everyone, I am Realine A. Langsab, BSED Math second year, and I am one of the Group 2 reporter, and I will gonna tackle the basic sine, cosine, and tangent equation. But I will discuss only the sine and cosine equation. So in doing our basic sine, cosine, and tangent equation, we must have a unit circle. So what is the unit circle? Unit circle is a circle with its center at the origin of 0, 0 and a radius of 1 unit. So angles are always measured from the positive axis, also called the right horizon. And we have the angles measured counterclockwise have positive values, and angles measured clockwise have a negative values. Let us first solve the equation for sine. So we have a given of sine x equals negative 1/2. So now, where on the unit circle is the sine value of negative 1/2? So take a look in our unit circle to know where is the value of sine equals negative 1/2. So as you can see, the value of sine is in the quadrant 3 where we have a value of x equals 7 pi over 6, and in a quadrant 4 where we have a value of x equals 11 pi over 6. So therefore our sine is equals to 1/2, or our sine x equals negative 1/2 is equal to x equals 7 pi over 6 or 11 pi over 6. So, but if we want all solution, we could go another loop around this unit circle and come up with more answer. A loop around the circle is 2 pi, so if we could add 2 pi to our answer, we could get more answer. We can add more 2 pi and get more answer. So, all solution to the equation sine x equals negative 1/2 would be like that. So take a look to our answer. So now let's move to the equation of cos. So let's find all solution for cos where we have a value of 2 cos x plus square root of 3 equals 0. So what angles on the unit circle have this for a cos value? So first, let's get the cos x by itself. So we will have the cos x equals negative square root of 3 over 2. And take a look in our unit circle to locate where is the cos x equals negative square root of 3 over 2. So we have a quadrant 2 and quadrant 3 where we have a value of negative square root of 3 over 2 is to 1/2. So therefore, we will have the value of x equals 5 pi over 6 or 7 pi over 6, and all solution of 2 cos x square root of 3 equals 0 will be like this. So take a look in our solution.
Good morning everyone, I am Justin Villegas, BSED Math second year and reporter from Group 2.
Solve tan squared x is equal to 1/3 on the interval quantity of 0 and 2 pi. So 0 is, this is would mean only one loop around the circle. Get tan x alone, so let's cancel the square root sign and tangent, so we also cancel the squared. Tan x is equal to positive negative the square root of 1 over 3. So our tan x is equal to positive negative the square root of 1 over the square root of 3. And it is equal to positive negative the square root of 3 over 3. What angles on the unit circle have this value for tangent? This is our unit circle. So since it can be either plus or minus, there are 4 values. We don't add any to go around again because it says in the interval from 0 to 2 pi. Our x have an interval from 0 to 2 pi. So the value of our x is equal to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So let's find it in our unit circle. So we find pi over 6, 11 pi over 6, 7 pi over 6, and 5 pi over 6. So as you can see, they have the same value. The difference one is the sign, the positive sign and the negative sign. If the values that these trigonometric functions equal are not exact values on the unit circle, you will need to use your calculator. Solve cos x is equal to 0.6 on the interval 0 less than equal x less than 2 pi. You can use the inverse cosine button on your calculator. Make sure mode is region but remember that the range is only the top half of the unit circle and you want the whole unit circle. So you'll need to figure out the other value from the one given. From calculator, cos negative x 0.6 is equal to 0.93. This value is somewhere in quadrant 1. What other quadrant would have the same cosine value or same x value on the unit circle? In quadrant 4, this angle is 2 pi minus angle from calculator. So 2 pi minus 0.93 is equal to 5.35.
Good day, ma'am. This is Shalika Jane A. Garelao. Gonna report about the multiple angles of the equation. So now let's proceed to multiple angle equations. Let's solve sine 2x equals square root of 2 over 2 on the interval, the quantity of 0, 2 pi. We still asked where on the unit circle does the sign have this value. So 2x is equals to pi over 4 or 3 pi over 4. So notice that we have 2x, not x. So solve for x by dividing by 2. Therefore, the answer is x is equals to pi over 8 or 3 pi over 8. Since you divide the angle in half, x is smaller, so you need to take another loop around the circle because you only want answers between 0 and 2 pi. But by time you divided by 2, you'll still be in that interval. So 2x is equals to pi over 4 plus 2 pi equals to 9 pi over 4. Therefore, our x is equals to 9 pi over 8. 2x is equals to 3 pi over 4 plus 2 pi equals 11 pi over 4. Therefore, our x will be 11 pi over 8. So the solution will be all four values because they're all still in 0, 2 pi. So if you try another loop around, you'll find yourself larger than 2 pi. So next is solve for the cosine 2x equals to 0. So notice that it is not limited to a certain interval. Where on the unit circle does the cosine equals to 0? 2x is equals to pi over 2 or 3 pi over 2. Since this is not asking for answers on a certain interval, we need to consider angles that are just more loops around. We'll add k to pi. So the equation will be 2x equals to pi over 2 plus k 2 pi or 3 pi over 2 plus k 2 pi. So solve for x by dividing by 2. So the answer will be pi over 4 k pi or 3 pi over 4 plus k pi. So since the first angle pi over 2 equals to the second angle, you could also list the solution as x equals to pi over 4 plus k pi over 2. So solve for the square root of 3 tangent 3x plus 1 equals to 0 on the interval 0, 360 degree. So we need to isolate the trig function. So tangent 3x is equals to what? It's negative 1 over square root of 3. Where on the unit circle does the tangent have this value? 3x is equals to 150 degree or 330 degree. So solve for the value of x by dividing by 3. So the answer will be 50 degree or 110 degree. We need to consider a total of 3 times around the circle since we are dividing by 3. So let's add 360. two different times to get other angles that will still fall in the desired interval by the time we divided by 3. So 3x is equals to 150 degree plus 360 degree or 330 degree or plus 360 degree. So it is one more loop around. Next is 3x 150 degree plus 720 degree or 330 degree plus 720 degree. It is two more loops around. So next is solve for x by dividing by 3. So the answer will be 50 degree, 110 degree, 170 degree, 230 degree, 290 degree or 350 degree. So the solution will be all 6 values because they are all still in 0, comma 360 degree. So that's the end of my report about the multiple angles of the equation, and that's how we solve the multiple angles of equation. I hope you learned a lot.
So, good morning everybody, especially to our teacher. I'm Judean M. Almadin, your reporter for today about the trigonometric function. So, my report is the continuation of the report of the other members. So, we have cos x plus sin x is equals to 0. So, kung mapapansin po natin, meron po tayong two different trigo functions. So, kapag ganito, in this case, ang ginagawa po natin ay in-squared lang po natin yung both side. So, this one. Pagkatapos, kaya natin ginagawa yung square, in-squared natin yung both side para magamit natin yung tinatawag nating fold method. So, in this fold method, it will give us the answer of cos 2x plus 2 cos x sin x plus sin 2x is equals to 0. So, i-reorder terms lang po natin. So, 1 plus 2x sin x is equals to 0 because this side, it will give us the Pythagorean identity that equals to 1. So, kunin lang po natin yung sine term. 1 plus sine 2x is equals to 0. Sine 2x is equals to negative 1. Then 2x is equals to 3 pi over 2. Then our x is equals to 3 pi over 4. So, this side naman po ang tinatawag nating double angle identity. So, sine 2x is equals to 2 sine x cos x. 2x is equals to 7 pi over 2. So, our x is 7 pi over 4. So, we have 7 helpful hands for solving trigonometric equation. Number 1, try to get equation in terms of one trigo function by using identities. Number 2, be on the lookout for ways to substitute using identities. Number 3, try to get trig function of the same angle if one term is cos 2x and another is cos x. For example, use the double angle formula to express first terms of just instead of 2x. So, katulad ng ginawa natin kanina. Get one side equals 0 and factor out any common trig function. Number 5. See if equation is quadratic in form and will factor. Replace the trig function with u to see how it factors if that helps. Number 6. You can square each sides when necessary to enable you to use the Pythagorean identities. And the last one, if the angle you are solving for is a multiple of x, don't forget to add 2 pi to your answer for each multiple of x, since x will still be less than 2 pi when solved for. So that's all for today. Thank you. Now,
In trigonometric equations of quadratic type, when we don't have squared trigonometric function, we can use the Pythagorean identities. So if you have two terms with different trigonometric functions, you can try squaring both sides. So we have an example of cosine x plus sine x equals to 0. So we can use the Pythagorean identities. So we squared both sides and we must do whole side together, not each term. So open parenthesis cosine x plus sine x close parenthesis squared equals to 0 squared. So the result will be cosine squared x plus 2 cosine x times sine x plus sine squared x equals to 0. So we reorder the terms and the result will be cosine squared x plus sine squared x plus 2 cosine x times sine x equals to 0. Then, according to Pythagorean identity, the cosine squared x plus sine squared x equals to 1. Then, the result is 1 plus 2 cosine x times sine x equals to 0. Then, applying the double angle identity, the 2 cosine x times sine x equals to sine 2x. So, the equation now is 1 plus sine 2x equals to 0. So, get sine term alone. So, transpose the 1. So, sine 2x equals to negative 1. Where's the sine 1? So, the value of sine 1 is 2x equals to 3 pi over 2. So, we divide the 3 pi over 2 by 2. So, x equals to 3 pi over 4. So, remember to do another loop when you have 2x. So, 2x equals to 7 pi over 2. So, we divide each term by 2. So, we can find the value of x is equal to 7 pi over 4. These are the helpful hints for solving trigonometric equations. So, first is try to get equations in terms of one trigonometric function by using identities. Then, second is be on the lookout for ways to substitute using identities. The third is try to get trigonometric functions of the same angle. If one term is cosine 2x and other is cosine x, for example, use the double angle formula to express the first term in terms of just instead of 2x. And the fourth is get one side equals 0 and factor out any common trigonometric function. The next is see if equation is quadratic in form and will factor. So replace the trigonometric function with u to see how it factors if that helps you. So the next is you can square it each side when necessary to enable you to use the Pythagorean identities. And lastly, for hints for solving trigonometric equations, if the angle you are solving for is a multiple of x, don't forget to add 2 pi to your answer for each multiple of x, since x will still be less than 2 pi when solved for.